Hello student, in today's lecture we have to continue the chapter Superposition of wave. From that chapter we have to learn today's article is laws of vibrating string. Last time we already learned modes of vibration of string. In that we get formula for fundamental frequency of vibration of string is given by formula 1 upon 2L under root T by N. In this formula where N is fundamental frequency of vibration of string, L is length of string, P is tension in string, small m is mass per unit length. It is also called as linear density. Based on this formula we can write three laws of vibrating string. Now let me learn the first law. This first law is also called as law of length or first law of vibrating string. So this law is the relationship between this N and L when T and M are constant. So mathematically we can write N inversely proportional to L if T and M are constant. So this is the first law of vibrating string, that is law of length. So N inversely proportional to L. How we write it in word? N means fundamental frequency of vibration of string. The fundamental frequency of vibration of string is inversely proportional to the vibrating length if tension in string and mass per unit length of the string are constant. Same law we can write in mathematical way. NL is equal to constant. So here we can write N is equal to constant by L. So this L is shifted to this side, we get NL is equal to constant. Now after that the second law of vibrating string, and it is related to the tension. So second law of vibrating string or law of tension. Second law of vibrating string, or it is also called as law of tension. Now what is law of tension? So here mathematically we can write N proportional to square root of T. N and T relation by this formula. If L and M are constant, if L and M are constant, so this law we can write in word fundamental frequency of vibration of string directly proportional to square root of tension in string if length of string and mass per unit length of string are constant. So this is the law of tension. The same law we can write N divided by root T is constant. So this is the law of tension. Now third law, it is the relationship between N and M. So M is the linear density or mass per unit length. So law of linear density or law of mass per unit length. Mass per unit length. Okay, now pay attention here. It is a relationship between N and M. So by formula N inversely proportional to square root of M. So this is the relation. N inversely proportional to square root of M. Okay. If other two constant means L and T. If L and T are constant. So this law we can write in word. कैसे लिखेंगे इसे? So fundamental frequency of vibration of string is inversely proportional to square root of mass per unit length या linear density if length of the string and tension are constant. So this is the law of linear density or law of mass per unit length. Now next one, or the same equation we can write N into root N is equal to constant. Now here these three are the laws of vibrating string. Also, we know that small m in this formula is mass upon length. Mass of the string divided by length of the string. Let us use mass by capital M, length by capital L. The mass we can write density into volume divided by L. Density of the string multiplied by volume. Volume of the string we can write area into length. So area into length divided by length. This length get cancelled. Density into area is the mass per unit length. Or density as it is, area we can write pi r square. So rho pi r square is the formula for small m. If I substitute this formula in above equation, we get n is equal to 1 upon 2L under root T by M. Instead of M I can write rho pi r square. So this is the another formula. By that formula also we can write two laws. First one is law of density. Means density and fundamental frequency relation. And the second law we can write related to the radius and fundamental frequency relation. So law of radius of string. Okay. Now what is the law of density? See here the fundamental frequency and density, how they are related. So by equation you come to know that fundamental frequency is inversely proportional to square root of density. So this is the law of density. Here, so this is the similar to the law of, means related to this small m. Small m is given by rho pi r square. So here you can see this law of mass per unit length. Here L and T are constant. Here also in the law of density, L and T means length of the string and tension both are constant here. Now here the law of radius. N inversely proportional to square root of r square, or we can write N inversely proportional to r. So this is the law of radius. Fundamental frequency of vibration of string is inversely proportional to the radius of string if length of the string and tension are constant. So here, dear student, we finished laws of vibrating string. I hope everyone understood. Based on these laws of vibrating string, you have to perform two practicals in the syllabus of 12th standard. Both the practicals are related to the first law, means law of length and law of tension. In this practical, you have to verify the law of length, means you have to prove that NL is constant. Again, the similar manner, second law also you have to verify in that frequency tension relation you are proving. I hope everyone understood this. Thank you.